In this video, I'll show you how transformation works inside an agent flow. Think of transformation as a translator for data. One node may receive data in one shape, but the next node may need that data in a completely different shape. Transformation is what lets you bridge that gap visually, without having to write a full script every time. In simple terms, transformation gives you control over data movement. You decide what data should enter a node. You decide what structure should leave a node. That is why transformation is one of the most important parts of designing clean agent flows. Let's learn this with a practical action example. In this setup, onAction and reply are already present. What we'll do is add an HTTP request node in between, fetch product data, and then transform that raw response into a clean structure before it reaches reply. Add HTTP request node from node palette. Connect onAction node to HTTP request node. Connect HTTP request node to reply node. Open HTTP request properties. I'll quickly configure the request details for this node so we can fetch product data for transformation. Save the flow. Now run the flow once so we can inspect the raw response before mapping. Click the Run button. Then click Execute to run the flow. Open Flow Logs. Open the latest execution. Open HTTP request output data. What you're seeing here is the raw API response, and it contains many product fields. In most cases, we don't need to use all of this data directly. Instead, we reshape it into a simpler and more useful structure. And that's exactly where transformation helps. Now let's return to the Agent Flow configuration screen and set up transformation. Open Map and Transform on HTTP Request Output. Click the Output pencil icon. Before we start mapping, let's quickly understand this screen. On the left, you have the Output Schema Editor. This is where we define the target structure we want to produce. Think of this as the final shape of data after transformation. At the top in the middle, you have Input Source. This dropdown lets you choose which variable we are mapping from, for example, HTTP response body. Now, look at the two mapping panels. The left mapping tree is the source side, which is the data we currently have. The right mapping tree is the target side, which is the structure we want to fill. You'll also see context variables on both sides. These are shared values available during transformation, and you can map to or from them when needed. To create a mapping, drag a field from the source tree to the matching field in the target tree. Each connection represents one mapping rule. If a value needs calculation or formatting, open the transform expression and use JSON ADA. At the bottom, you can see how many mappings are active. Use Clear All if you want to reset mappings, and Save to apply the transformation. Now, select Input Source as HTTP Response Body. If response fields are not visible yet, that means schema is not generated for this variable. So now open the HTTP Request Node Variable Editor. Select Output Variable HTTP Response Body. Click. If you already have the response schema with you, you can directly paste it here and apply it. If you don't have it yet, we also support automatic schema generation. To do that, click Generate Schema. Paste the raw response sample and apply it. A schema is the data blueprint. It describes field names, data types, and how data is structured with nested objects and arrays. In this example, the HTTP node is fetching product data, so this schema should match the response format returned by that API. This schema is what Map and Transform uses to understand available source fields. If the schema is incorrect or incomplete, the HTTP response won't be interpreted properly, and mapping can fail or show missing fields. Once that schema is saved, those fields become available in source mapping. Now apply this generated schema and save the node. Now reopen Map and Transform and select Input Source as HTTP Response Body again. You can now see schema types clearly in the source tree: string, number, Boolean, object, and array. Objects contain nested fields, and arrays are shown with square brackets. This is especially important when mapping list data like products. Now click Generate Schema icon in the Output Schema editor. We generate this schema to define the exact output format we want the transformed response to follow. If the next node or another service expects data in a specific format, you must use that exact schema here. That way, transformed data is passed forward exactly in the expected format. In our case, we want the output in this format: a report section for summary values and a catalog section for simplified product rows. In report, we have summary fields: total products, top-rated product, average rating, min price, and max price. In catalog, we have an array of simplified product objects with ID, name, category, price, rating, and stock status. This structure separates overview data from item-level data, so the next node can consume it easily. This target schema is what Map and Transform uses as the destination, where source fields are mapped into target fields. In simple terms, source schema tells us what data we have, and target schema tells us where that data should go after transformation. Apply the generated schema. Now map the products array into the catalog array by aligning each product field to its simplified target field. Map product ID to catalog ID, title to name, category to category, price to price, rating to rating, and availability status to stock status. This gives you a clean, compact catalog structure while preserving the key information you need. For calculated values, use expressions. Our platform supports JSON ADA expressions in transformation mapping. For the report section, we'll use expressions because these fields are computed values, not direct field copies. So instead of dragging one source field to one target field, we write logic in the expression input for each report field. Now for the report fields, we'll use JSON ADA expressions instead of direct mapping. I'll enter each expression one by one and explain what it gives us. For total products, I'm adding an expression with using count function. This returns the total number of products in the response. For top-rated product, I'm adding an expression that picks the highest-rated product and returns its title. This gives us the best-rated product name in one field. For average rating, I'm adding an expression to calculate the average rating and round it to 2 decimals. This gives us a clean summary value. For min price, I'm adding an expression to fetch the lowest price from the list. This gives us the minimum price point. For max price, I'm adding an expression to fetch the highest price from the list. This gives us the maximum price point. This is exactly where expressions are useful, whenever the target value needs calculation, selection, or formatting. And if you want to explore more functions and syntax patterns, you can refer to the JSON ADA documentation directly from the docs section. Now run the flow again. Open flow logs. Open the latest execution. Open HTTP request output data. Now you can clearly see the transformed output structure we created. Instead of the full raw API payload, we now have a clean report section and a simplified catalog section. In report, you can see computed values like total products, top-rated product, average rating, min price, and max price. In catalog, you can see only the fields we selected for each product, like ID, name, category, price, rating, and stock status. Now open reply node input in the same execution. You can see this transform structure is passed forward directly, exactly in the format we designed. Now let's move to a more advanced transformation example. In this part, we'll extend the same output we already built. Inside each catalog item, we'll add 2 transformed arrays, labels and review report. The goal is simple. Product-level fields are already mapped from the previous step. Now, we only map tags into labels and selected review fields into review report. Go to the same agent flow we configured earlier. Open HTTP Request Output Transformation. Now we'll update the same target schema by extending the catalog section. Click Generate Schema in the Output Schema Editor. I already have sample JSON prepared, so I'll paste it and generate schema. In Catalog, we are adding two new fields, Labels and Review Report. Labels is an array of strings, and it comes from product tags. Review Report is an array of objects, and each object contains only reviewer name and comment from reviews. Now apply the generated schema. Now, map source fields to target fields. Since product-level mappings already exist, we only map the new array fields. First, map tags to labels. This is array-to-array mapping, so each product keeps its own labels list. If a product has two tags, it will get two labels. Now, map reviewer name from reviews into reviewer name in Review Report. Then, map comment from reviews into comment in Review Report. Here is what happens after this mapping. For each product, Transformation reads its reviews one by one and creates Review Report entries with only those selected fields. So, if a product has 3 reviews, that same product gets 3 Review Report entries. That keeps the output clean, but still complete for the next step. Save Output Transformation. Save the flow. Now run the flow again. Open Flow Logs. Open the latest execution. Open HTTP Request Output Data. Now you can clearly see the transform structure. Each catalog item includes product details, labels from tags, and review report from reviews. Each product gets review report entries based on the number of reviews that product has. That's how nested array transformation works in an agent flow. You can reshape array data at multiple levels, so the output matches the exact format the next node expects. The biggest benefit of transformation is that it removes guesswork. Instead of forcing every node to accept the same data format, you adapt the data exactly where it is needed. That makes agent flows easier to build, easier to read, and much easier to debug. My recommendation is, use transformation for shaping data and use custom JSON data expressions when the mapping is slightly more advanced. And that's how transformation works in an agent flow. Thank you for watching. Now go ahead and try this transformation flow on your own and experiment with both direct mappings and JSON data expressions to shape data exactly the way your agent flow needs.